Can I just say, this is the first time I've seen the animation. It is phenomenal. What?
Libby Berry on the heckle mic.
Hi.
Did you miss me? Hi. It's Lightning Talks time. How are we? Yes. Yeah, applause, applause. Stop.
Again.
4 years out of practice and you don't need any training. Amazing. Okay, today we have 11 talks on a variety of themes. Basically, first thing I'm going to run through how this works. I'm going to introduce our upcoming speaker. Before I do that, I will always introduce the person who is up on deck. If I say your name and you're up on deck, that means to go to the lectern that I point at, so that we don't have any breaks between our talks. Awkward silence is really awkward, and Libby will have to stay stuff.
Yes.
Okay, really important is that we keep this thing to time. Russell here has a laptop, so speakers, look at Russell. He will tell you exactly how much time you have remaining in your talk. When we get to about 10 seconds left, somebody in the audience will start encouraging you to make some really quiet applause with your fingers. And then suddenly it will start turning into applause with hands. And then when we hit 5 minutes, you need to make really loud applause so that the people know to get off stage. Yay! And up first, Nikki Ringland.
Okay, hello. I'm going to talk about, well, it depends. So here you are, you're working on your amazing, awesome project, and you find yourself installing a dependency. That's great, but hang on, what even was that? What did you just install? Good news, I have live footage of your yes, no, okay. Here is your lovely dependency tree. It's beautiful, and oh no, there's been a vulnerability or an incompatible license that's just been discovered in that tree. If you are lucky, the problem is in a direct dependency of yours. If you are unlucky, it might be in an indirect or a transitive dependency. The problem with this is that it means that you might need to wait for that intermediate package, or maybe all of those intermediate packages to fix before you can actually patch that problem. So you might have to wait for them to remove that bad dependency. You might have to remove the entire path that pulls in this dependency, but this involves considerable effort. You added that dependency for a reason, right? A good reason, right? And then, of course, there's the problem of your beautiful, nice, clean dependency tree does not look like this. It usually looks a little bit more like this. It's a graph, and probably a pretty interconnected one. And that problem package, that one down there, well, there are lots of different ways that you depend on that. Now, in Python, we're not doing too badly. We've got Flask, that's a reasonable number of dependencies. You might be using Django, that looks great. Or you might, oh no. And other languages, well, I'm not naming names here. So a median thing in languages like Go or Python, on the left here, we have about 10 dependencies, but in languages like Rust or JavaScript, more like 70 or 80. That's a lot of dependencies to keep track of. And why would you want to keep track of dependency? Oh, yeah, those problem things. Some of you may remember. Look, don't worry. There was a problem, log4shell, but it was okay because they patched it pretty quickly. That's great news. All you need to do is pull the new version, bump your dependency version. The bad news, you've got to bump that dependency version. This is hard because in Maven and Java, they use this thing more often than not called a soft version requirement, which means that manual effort was needed. Manual effort is bad. Also, it turned out that log4j ended up more often than not really deep down in the dependency graph. This is the depth at which log4j first occurred in that dependency graph. And if it's 5 layers deep, you've got a lot of people who need to do manual effort before you can actually fix your problem. So your problem more looks like this. Uh-oh. But we're not Java. We're not Maven. We don't have these problems, right? Well, what would happen if something similar happened in a different ecosystem? So things like NPM and pip, the resolution algorithm prefers more recent versions, so that newer, that fixed version is automatically pulled in. Okay, look, there are some weirdness that happens in other languages. NPM might give you the old version and the new version, but we won't get into that. The new patched version is going to be automatically pulled into your dependency trees. You win, unless the new version that you just pulled in actually introduces a bunch of problems, like what happened recently-ish. A developer pushed deliberately breaking versions of their dependency, and then that was automatically propagated across the entire ecosystem. When NPM stepped in and removed the versions, it's all a giant mess. Dependencies are a giant mess. What is better? Do we pull in the new versions? Do we leave the old stable versions? I can't answer that. I don't think I can even answer this one. What do I do? One of the things you can do is watch Evan's talk from yesterday if you've got time travel or can access the stream later. Another thing you could do is look at your graphs of your dependencies on deps.dev and, not despair. But I kid, but really knowing is very useful. So this is a dependency graph. Look at these are all the paths to the advisories. Maybe you only want to look for one particular advisory. At least knowing the scale of your problem is a start. OK, so please go and fix this for us. Use our data. You can get it. It's free. You don't even need an API key. Go to deps.dev, use the API, use the BigQuery dataset. Please, won't someone fix this for us? Thank you very much.
How do you think Mummy went?
Everyone's a critic. God.
Yeah, thanks, Nikki.
Did anyone else's shoulders raise in solidarity when they saw the dependency graph that looked like a mess? Because mine sure did. No.
Right, up on deck we have Terence. But first, Daniel is going to talk about crowdsourced databases.
Hi, everyone. It's good to see you all in person. So I'm going to talk a little bit about Music Brains first. It's a crowdsourced database of CD information and other music information. So if you've heard all the music that goes on in between sessions and you're joining online, that music's done by Citrix. We've got Music Brains has got millions of artists. If you find an artist, we've probably got it. From Python perspective, I want you to go and download Music Brains to Picard. It's a Music Brains tagger. You add your music to it, and you'll hopefully get metadata. So this is the Beatles. It's got, I don't know, barcodes and all that sort of thing. So this is sort of a project that I sometimes do on the couch. So if you've got a couch and if you've got a laptop, feel free to create an account and see if there's anything missing. Tag all your music, and if it's missing, feel free to add it. Once you get past the basics, notice there's lots of things like external links. So find people's social media handles, find their SoundClouds. Feel free to add that sort of thing if it's missing. If we go to some of the other artists, we notice we've got a summary from Wikipedia. That's linked through a project called Wikidata. So if you haven't heard of Wikidata, that's the data behind lots of Wikipedia pages. The problem it's trying to solve is you've got all these different languages. So you're going to have your Spanish version of the Wikipedia page to the English version of the Wikipedia page. There's a whole bunch of facts. And a place to put all those facts is Wikidata. So if you go to a Wikipedia page, it's things like these info boxes. That all gets populated by Wikidata. So things like genre, you only have to apply that in one place, and all the Wikipedia pages will instantly be updated if they use the right templates and that sort of thing. So once you've tagged your music, the next thing is to start to Wikidata if needed. Then you can extend that to Wikipedia. The interesting thing for me when you're trying to link these things is the authority control template, which links several different databases that are there for music. So there's all the rights organizations of who actually write the songs and things like that, that all cross-links. Probably, if music's not your thing, go to OpenStreetMap. If you ever played Pokemon Go and the map's not quite right, you see a road that's sort of a meter off, they all import OpenStreetMap data. So all you need to do is create an account. It's got a web-based tool, and you can just move the lines slightly so it all matches properly. If it annoys you, feel free to fix it. There's other crowdsourced things like scientific things. If you've heard of Galaxy Zoo, they were trying to classify different types of galaxies, so spherical and spiral. Feel free to look for these sort of things, but while you're on the couch, feel free to do something useful. Thank you.
Hey, thanks, Daniel. I saw Amanda Hogan's talk before the afternoon tea break, and seeing the difficulties you had fighting through trying to scrape Wikipedia and seeing this Wikidata stuff makes me excited for how much easier it could be trying to expand on those sorts of things. On deck, we have Gerard Hogan, but first, we have Terence Hun, who's going to talk about our favorite airline.
So evidently, I don't work for Qantas nor its rivals. I just want to say that for transparency. But I wanted to talk about this because it's surprising how much we sort of forget or forgive many companies for some of the bad practices they do about security. So before the world ended in 2020, I managed to squeak out one last flight. It was a work trip, flying back from London to Melbourne via Dubai. I was sitting in my plane seat, about to turn my phone on to airplane mode, when my phone, still somehow connected to the airport Wi-Fi, got 3 notifications. One from Instagram, one from Facebook Messenger, and one from Gmail. I didn't reset my PIN though. Well, crud. There's kids around here, I didn't want to swear. But yes, I only found out after when I landed back in Melbourne that the person who hacked me was my friend. According to them, they kind of wanted to test it out and thought it wouldn't be that easy to hack me. I'm still whether or not to press charges. I'm still considering that. However, I didn't know that my friend was the one that hacked me during my flight from Dubai to Melbourne, so I did what any rational person would do. I purchased a super expensive plane Wi-Fi so I can try and recover my account during the long flight. And yes, as you can expect, the internet speeds on a plane flying across the Indian Ocean isn't that fast. But I persevered, and despite the numerous network timeouts and long waiting screens, I managed to change the PIN to something that I know. How, you may ask? Well, I'm not sure if this is the current process, but back then, Qantas would ask these 4 questions to verify my identity. And yes, these are the same questions that my friend got asked as well. I only needed to answer 3 of the 4. And looking back, you can realize how easily accessible this sort of information is, especially if this is the person that you trust, like a friend. For example, my birthday was available to all my friends on Facebook and Twitter. And if they've been a friend for a long time, like let's say back at high school, it's pretty much game over. So first lesson, don't make your security questions on easily obtainable answers. Now, when I wrote an article about this back then, this was going to be a massive rant, but they changed it. So now you can change the security questions to be something else, you should review them. I recommend you do review them. The new set are slightly better than the previous one. Instead of asking your date of birth, they ask, like, what's your favorite book? Okay. I especially do love the miscellaneous word or sentence option, because you can effectively make a verification password. So if you use something like 1Password, you can just create another password field, and there you go, Bob's your uncle. Bit of a side note, please, please, please stop using SMS as a multi-factor authentication option. We all know why this is bad. It is, however, the most accessible option. But, and all of us are here, great thinkers and all that. We really should get rid of it. This is ironically the only thing I agree with Elon Musk. We should get rid of it. It must go. Fun fact, Qantas actually now offers multi-factor authentication through an authenticator app. So if you didn't know that, congratulations, now you know. I'm not saying this is something to do with an article I wrote 2 years ago, but the only bad thing is it doesn't extend to all Qantas services. So, for example, Qantas Money. So if you have a Qantas credit card, this is going to protect you. Fun fact, Qantas Money is actually owned by NAB. Number 3, your Qantas frequent flyer number can give you access to everything. We all think it's some sort of membership number, right? But the amount of information that's connected to it kind of concerns me. For example, you can actually walk up to a self-service kiosk, put in someone's QFF number, and you got someone's ticket right there. Or you can get away with a lot more information than just a booking reference. Now, if you're a social media influencer, they no longer print this information, thankfully. Qantas did this since October 2019. Virgin did this in March 2020. But not all airlines do this. Emirates is a code share, they still print it. Oh, so why are we still doing this in 2023? There are this, how a new combination. So we should change that, Qantas. Please fix this. Thank you.
Hey, thanks, Terence, and thanks to your mother, Ms.
And an extra thanks to your friend for providing excellent lightning talk material.
Up on deck, we have Nick Crouch, but first, Gerard Hogan, who's going to tell you something that you really should know.
Hi, thanks everyone. Yes, I have to start with a confession. First, I have no slides. Secondly, I am not a coder, but all of my friends, all of my family, and most of my co-workers are. So this is something that is kind of near and dear to me. Yes, also there are 4 related Hogans here today. It's not a coincidence. But what I do for a job is I talk to people. I'm a user experience researcher, so I go out into the world and talk to people about what they like about the apps that I work on, what they hate, what they want, what they wish they'd do, and what they really wish we'd stop doing. So I feel incredibly privileged to be able to do that, because I get to see the hard work that our developers and designers put into building things out in the world and see how people actually interact with those things. And if I could sum up what I've learned in all the years that I've been doing user research, is that you are not your user. And I guess what that comes from is seeing people try things in the real world and being alarmed at how they try and do things that you never thought they'd do with your apps. To tell you a bit of a story about that, I used to work for a bank, and when I worked there, I was working on the first generation of our iPad app. So yes, it really was a very long time ago. And we built this beautiful app that actually won a ton of design awards. And we released it into the world, didn't get used very much, feedback was terrible. So we sat there and looked at it and thought, what is going on? This thing is beautiful. So we went, a couple of researchers, we went out into the world and spoke to people and gave them the app and said, okay, do some things with it. And what we found was people looked at it and said, looks pretty, but it doesn't do much. And we're sitting there going, what do you mean it doesn't do much? It has all these amazing interactions. You can drag one account on top of the other and have it transfer money. It's beautiful. But the interactions were not discoverable. And so this is the root of the problem, where you can spend a lot of time building something and you get so caught up in it that you don't realize that for other people, it's not discoverable. And so I guess what I'd like you to do is bring that story back into your own work and think about all of the things that you're deeply invested in, that you've spent all of this time developing, and chances are it's because what drew you to coding in the first place, or the thing that you're working on now, is because it's something you care about deeply and something that you want to use yourself. But maybe think about all of those things and whether, say, my mum would be able to use them. Now, granted, that's a hard thing to do, to put yourself in someone else's shoes. And so that's where user research comes in. Go out into the world and talk to people. And honestly, the easiest thing to do is to give someone your app or your website or whatever it is that you're working on and say to them, do a thing. Tell me how that goes, and watch them. And generally, you might be alarmed by what happens. Designers often get very upset when they see people doing things in a way that they didn't expect, or they've changed the font size and it doesn't make any sense. Things don't fit on a screen anymore. So there are a ton of things that you learn only by talking to people. And there are easy ways that you can do this. You don't need to be an actual user experience researcher. You don't need to use expensive tools. There are things that you can find on the web, like 5-second test lets you test designs. SurveyMonkey lets you build and send surveys out into the world. So there are things that you can do yourself to gather some of this knowledge. So if I could bring you back to my I want to put this on a t-shirt slogan, is that you are not your user, and anytime you spend thinking like a researcher and being out in the world and talking to people about how they might want to use your thing is just going to make your end product better. So that's it. Thank you very much.
Thanks, Gerard.
I am absolutely first in line for those t-shirts. That sounds fantastic.
Is not our user, but was the presenter of You Are Not Your User, which you were, but you're not a user. Nick crouches up on this lectern. But first I have a card that says this question will not be answered. What is the question? Let's ask Jess.
Right, so I would also like to preface this by saying I am not a coder. I don't know anything about almost anything tech related, but I do know about the Fast and the Furious movies. This started because I realized that every single one of the now 11 Fast and the Furious movies have a different naming scheme. And I don't quite understand how they've managed that. And I'm very, very excited to see what they do with 10.2 and possibly 10.3. So I'm just going to list them off very quickly. We have The Fast and the Furious, Too Fast, Too Furious, The Fast and the Furious Tokyo Drift, Fast and Furious, Fast 5, Fast and Furious 6, Furious 7, The Fate of the Furious, F9, and Fast X. And then there is the offshoot, The Fast and the Furious Hobbs and Shaw, I think it's called. So as I was looking at these, I thought I'd just write a couple of words about each of them so that we can all be on the same page. So number 1, we've got Paul Walker, we've got Vin Diesel, they're friends now. Number 2, that's the first one without Vin Diesel in it, which is interesting because these are a Vin Diesel passion project. Number 3 is once again without Vin Diesel. It's the Tokyo Drift one. It's... We're going to come back to Tokyo Drift. It's, right. Number 4, doesn't seem to matter at all. Number 5 is the best one. Number 5 is the one where The Rock becomes part of the crew, I guess. And it's the one that the current X plus X2 plus X3 is trying to go back to. And we will come back to that as well. Number 6 is the one where Paul Walker passed away. And that became a bit of a problem because instead of having his character die, they kind of just made him drive into the sunset literally. Which becomes a problem once we reach the end of the series because now everyone's come back for this big end thing and Paul Walker's character kind of just looks like a bad guy because he's not coming back to help his friends. So they maybe should have just, made that go away. So, number 7 is where we have Jason Statham join the team. Well, he doesn't join the team. He's the bad guy. Also, spoilers, obviously. But also, number 7 is where we have introduced our 3rd bald main character. No, fourth bald main character. Number 8 is there's a lot of stuff with Charlize Theron and there's a submarine. Number 9, that time they actually went to space. I am not joking, they go to space in the 9th movie. Number 10, we get John Cena, which is a fun addition. And it is the end, except they've confirmed there's at least one more, if not two more. Right, so I want to go back to Tokyo Drift to explain the insanity that is the timeline of these movies. They mostly are in order, except for Tokyo Drift. They got to Tokyo Drift and then decided to keep making movies afterwards. They kind of finalized it and then went, no, we'll just keep going. So there is a character from Tokyo Drift that is then killed off in that movie and shows up again in the next one. So in order for that to happen, they decided to put number 3 in between 6 and 7. But then they got to number 6 and decided they still liked the character. So they retconned it again and didn't kill him off. They put an after-credit scene where he mysteriously didn't die. And they've done similar things 3 times now. There are 3 characters who have died in a movie and then have come back. It happened with a brain damage amnesia situation, and it is now about to happen. We don't know why, because it was mysteriously suggested at the end of X that another character is coming back. Honestly, these movies, they're just ridiculous, and I love them so much because of that. They stopped being about cars in 3. They became action movies in 4 and have just gone off the rails since then, and I love them very much. And that's it.
Thank you, Jess. It's good. We have more link jokes from a lightning talk than we've had in years, which is great. I found the list of 10.3 and 10.4 names. We have Tiger, Jaguar, and Panther.
Yeah, personally, I'm looking forward to beta testing Fast and Furious Sonoma Drift. It's going to be good. I'm expecting big things.
Up on deck, we have Alistair Robertson. But first, Nick Crouch.
Hi, I'm your friendly neighborhood sponsorship coordinator. First of all, brief clap for the sponsors. Thank you. Stop.
No ads.
Quick show of hands, who's heard of Streamlit? All right, so there's a number of you in the audience. This is not going to be new to you. I'm very sorry for that. Maybe there's some new stuff before me that you didn't know about already. Yesterday, sitting in the student showcase, I noticed there was a lot of conversations and a lot of starts to talks that went, I wanted to build a thing, and then I got out Flask, and I've learned HTML and JavaScript, so I could use Flask really easily to build a UI. And I'm sitting there and I'm thinking, I mean, these kids are amazing, really. Like, to be upfront, if you missed the student showcase, go back and watch it. I think it'll be on YouTube because it's awesome. But I was sitting there thinking, this is not HTML and JavaScript column, this is PyCon. So with that in mind, I want to show everyone in the room how you can really quickly build some apps in Python that aren't Russell's thing, and I apologize for that. So this is Streamlit. On the left-hand side, you can see the code. On the right-hand side, you can see the output. So I've got my st.stop here. All that's going to do is act like a breakpoint. So when I hit Control-S, you can see it says the source file has changed. I'm going to hit always rerun. So every time I change my input file, it's going to refresh the page on the right-hand side. So now what I can start to do is really, really easily build in some data entry or data exfiltration from somewhere. Exfiltration is not the right word. Don't do exfiltration. And yep, that's saved. So now I've got my my load data. I've told it where to go. And so now, actually in the background, we've defined that method, and it's reloaded on the right-hand side. You can see I've got cache data in here. We'll come back to that in a second. So now I'm going to come down here. I'm going to put my st.stop after this block of code. Going to hit Control-S. You can see I'm now running load data because it's refreshed on the right-hand side, and it's starting to do the thing that I've asked it to do. You can see that's basically go and load the data, get 10,000 records out of it, and that's been done. Fantastic, excellent. Okay, so you've got some data. What do you do with it? Well, first thing is, let's take a look at it. Looking at data is really, really easy. Looking at data consists of st.write data frame. Now I've got some data that I can look at. Great, I can scroll through my data. That's OK, fine. This is a data set from Uber. Nobody cares. It doesn't matter. In fact, it's more interesting if you chart it. So st.barchart gives you a bar chart. It is literally just passing in a histogram. That's pretty easy. Now let's say I decided that rather than just knowing how many rides I'd take during different hours of the day, I'd prefer to know where I took those rides. That's pretty easy as well. I can just use st.map to do that. So now I have a map of all my rides. So if you've got geospatial data, you can start to map that within, 3 minutes and 30 seconds. Let's say rather than just mapping all your rides, you actually want to know like where do you go at certain hours of the day. I've got a colleague that did this with people getting picked up at various times of the day in London on their bike system. He found somebody that took like 4 hours to go 2Ks. It was not the straightest of trips, if you know what I mean. So from here, I've got a slider. I can take my slider, move it, page refreshes, I get a different cut of the data. Take my slider, move it across here, page refreshes, I get a different cut of the data. That's because over on the left-hand side here, I have my hour to filter is an st.slider, right? So very easy to build input to that data. We also have code blocks in Streamlit. That's pretty easy. Let's go ahead, st.code. All of a sudden, now I have a code block with syntax highlighting. And last but not least, it has notifications. And it's last but not least because I'm going to run out of time. So you can see down the bottom here, it has notifications. So if you want to really quickly and easily build out an application to explore data, show data, do anything you really want with data, and you don't want to have to learn HTML, I don't want to learn HTML, go ahead, pip install Streamlit, and then the command is literally app run or Streamlit run app.py. You're done. Thank you.
Nick Crouch, everyone. In no way saying that the kids in the education showcase were doing too much work. Sorry, he was saying that some of them were doing too much work.
But you're doing it really well.
Yeah. Up on deck we have Kate, but first, Alistair Robertson with Python for Infrastructure as Code.
Hello everyone and welcome to my PyCon talk. This is my first ever conference talk, so thank you for the opportunity. Okay. I'm a DevOps engineer. I work for a Canberra-based company called XRD, and I kind of love Python. I'm going to talk about infrastructure as code, why we picked Pulumi and Python, and the tech stack we use to manage thousands of resources across multiple AWS accounts. When I'm talking about infrastructure as code, I'm talking about describing our environment in some way and having that description deployed with automation. This is the alternative to that deploying by hand and documenting in Confluence or never documenting at all that some of us are familiar with. In my world, the AWS world, infrastructure doesn't only mean servers and routers. It includes a plethora of value-add managed services like Amazon GuardDuty and Security Lake, anything that can manage with an API. In general, the stages for managing your infrastructure with code begin with declaring your resources in some way, and then their dependencies on each other. You then schedule the ordering of deployment, so you can deploy as much in parallel as possible, and you execute. Finally, you manage your state somewhere so you can make changes or remove infrastructure later on. I'm sure that the majority here has heard of Terraform, but did you know that you can declare your resources as though you're instantiating classes in Python rather than a perhaps unfamiliar domain-specific language? And to Pulumi, it's a competitor to Terraform and allows you to do just that, along with being able to leverage many other fancy language features you might want to use. Other languages are also supported, but we are at PyCon, and Python is my choice anyway. Pulumi has a great feature called dynamic resources, where if we need custom resource functionality, you can write that in your own code, but have it play nicely with the resource state model, which we found you need pretty heavily when you hit rough edges with working with AWS. Why would I want to use a programming language to declare my infrastructure rather than something with more rigid structure? I'll tell you why. Complexity. With great power comes great responsibility, and with a large environment comes complexity to manage. Our deployments span many AWS accounts, each performing different roles and resources having cross-account dependencies. As such, a very high-level view of our cross-account dependencies looks a bit like that. Which, as you can imagine, is a bit of an ordeal to explain to new team members. For the AWS people here, these dependencies are for use cases like cross-account log delivery, golden AMI building, and generating service control policies. We didn't just pick Pulumi and Python on vibe alone. We built out a test case of a cross-account transit gateway attachment in Terraform, Pulumi, Ansible, and a heretic blend of Boto 3 and CloudFormation, so we chose the one that went with Pulumi. Setting this up involves a lot of jumping back and forth between accounts. Writing in Python was the nicest fit, especially with a team that was already comfortable with Python, and we moved forward with it. And so was born Project Skywater. The name Project Skywater is a nod to a weather modification program by the US Bureau of Reclamation in the 1970s, and they were performing cloud seeding to control the weather. Unlike Reclamation, though, and their rain clouds, we've had much more success with the digital cloud. All right, let's walk through the tech stack and talk about the moving parts. First up, we're building Skywater around the Pulumi library. So we need the Pulumi engine, which is a Golang binary, taking care of the scheduling problems and deploying resources. We then also have the Pulumi Python library, which we use in our code, and they have the class definitions that we instantiate to represent a resource trait in AWS. Of course, it's never quite that simple. The Pulumi engine doesn't actually know how to request resources from a cloud provider. Various Terraform providers are wrapped to provide that implementation. They sit underneath the Pulumi engine. Now we have our actual code base. At my last count, we're sitting at about 71,000 lines of Python, not including various configuration files. That's just talking pure Python. That's where the codification of the overall environment and the network designs exist. Notice the suspicious space between the Skywater codebase and the Pulumi components. I wonder what could possibly go there. It's more Python. We directly depend on, I think it's like 30, and then indirectly on over 100 Python libraries. But surprise, that's not all the Python. We have more Python code implementing dynamic resources rather than that sit underneath the engine rather than over the engine, because they're performing the same job as the resource providers. I'd like to take a quick moment to note that everything in that sandwich between the Skywater codebase and our dynamic provider code are open source projects we're using. They're all developed in the open, free to use, so we do lean quite heavily on the open source community and free as in speech software, giving back in the form of hopefully detailed bug reports and delving into the code in various places. At this point, we have a nice little stack of things, so here are some services we're having the various bits work with. And finally, up to this point, where has Skywater been running? The answer is probably my laptop. That's not exactly great for production environment, but as you can see, there's lots of bits to install or update independently. And so, Docker to the rescue. Wrap up the toolchain, and voila, works on my machine, works on your machine, works in the cloud. Thank you for listening to my stream of consciousness. I hope it's been useful.
I feel like no gigantic architecture diagram is complete without Docker in it these days.
And I feel like this is also a fantastic reminder that lightning talks are a fantastic way to get new speakers or new people in the community used to presenting to an audience. So I highly, highly encourage, if you're at all curious and has never done it before, sign up for a lightning talk. The box will be open again tomorrow. We will be running lightning talks again, same time on Sunday.
Yeah, and this was Libby like 2 in-person PyCons ago.
Oh boy,
and
yeah.
look what happened since.
Yeah. I don't know if that's actually a selling point.
Submit for lightning talks tomorrow.
Yeah.
Yeah. So up next, we have another person who's been really busy organizing the conference and volunteering in these sorts of things. And they've been so busy that they haven't been able to do 2 of their favorite things during the weekend. And we're just going to give them 5 minutes to do that.
Thank you so much. My 2 favorite things are playing...
Sorry, on deck, Malcolm Ramsey.
Yes. My 2 favorite things are being anxious and playing video games. We're going to play Celeste. So I sometimes complete this level in 5 minutes, and sometimes I don't. So you might have to clap me off, and I may not leave. My name's Kate. My pronouns are they or she. Either way, one works. I have the things: ADHD and anxiety. Recently, I learned to do a meditation that actually works for people with ADHD. Which was really surprising. And it was that we went around a circle and we held like a fidget toy or a pen in our hands and we described a few things about it. And it really reminded me of the things that I do in video calls when I'm really bored and no one's looking at me. Which is I play this level of this particular video game quite fast. This is Celeste. It is a wonderful game. It's about anxiety, being trans, and climbing a mountain. Ooh, 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 ooh.
No! Oh!
I've got about 1,000 hours in this game, so you don't have to be like this.
But we will anyway.
The things that I liked about the meditation session that I was in, and I'm sorry that I'm not making eye contact, it's because I have to look at the video game in order to not die. Oh my gosh, please. Let me up, thank you. There's the wall bouncers. Immediate death. The things I liked about it as like a reminder of the different ways that we can do meditation is that this is a precision, repetitive, a pattern that I have done repeatedly many times. But I have to pay full attention to this game, except when I want to give a talk at the same time for some god unknown reason. But you have to think about it, and what it does is it quiets up one of the tracks that's always running in the back of my brain. And it says, you can't think about that right now, you're playing video game. I always used to be playing like beat games like Chime when I was in high school, when I was on video calls, or Trackmania. If I played Trackmania, I would be swearing a lot more. So we're playing Celeste today. The other things that were part of that were being aware of like the contents and the attributes of the thing that you're looking at. We were talking about our pens or our fidget toys as like, I'm just going to reset that, as like, this thing is cold, this thing is smooth, this thing is hard. In this case, I'm thinking, I'm slightly short on that jump, I didn't extend that jump, my hair is the trans color instead of the gay colors, and that means that I'm not going to live for very long here. But we're all good here, this one's absolutely fine. I could do the really fancy trick, but I don't know it, so I'm really... I usually don't die there. Oh no. 1 second. The other thing that is really good when you're giving a presentation about speedrunning especially, is that you can just take a second and regather your thoughts. Gee. Ooh, ooh. And it's okay. Doing something that doesn't really matter, that's pretty good. I'm not going to be able to finish the map in the 5 minutes now, but that's absolutely fine. This is a really long screen to die on. Some things matter more than others, some things don't. But taking a moment to breathe, to be aware of the wind, as we can see the wind is quite strong here, so we're breathing pretty fast here. But now it's stopped. Having backups, having another idea for if something goes wrong, you can have something else that you can do, and having that as the background for being aware of, oh jeez, that one was close. Last time I gave a very similar talk at my work, I put about 3 F-bombs in that, so I'm doing really well. If anyone heard me say gosh, that took practice. The other one that I like here is that it's always progress. Because failing in this video game is such a low cost, as we can see here, that cost me about 3 seconds, and I'm failing a lot, and I still look like I'm pretty good at the video game, right? The cost is pretty low, and it doesn't matter all that much. Thinking. Yeah, alright. Now we're going up. We're just going to remember to breathe as we bounce up here. This is actually the final screen, which would be very funny. I didn't die. Thank you very much, everyone. Enjoy breathing.
Thank you, thank you, thank you, thank you, thank you. Cut him off, cut him. Hey.
And honestly...
Cut.
Honestly, props for getting through it and talking. I couldn't do that.
What are you doing, AV people? Why'd you put it back on?
Keep doing what you're doing. You're doing great.
How dare you?
They're doing great.
Right, Ella Pietroia on this side. I mentioned there'd be a variety of topics. 1 talk or 2 talks which are not on a variety of topics, and here is the second of those talks. Malcolm.
All right, so I know some of you have to fly home tomorrow, unfortunately, and you want to attend as much of the conference and the lightning talks as possible. So how late can you get to the airport and still actually make your flight? So there's an easy answer, which is never. You just stay in Adelaide. That's worked out pretty well for me. But you actually have responsibilities, so you should probably go to work tomorrow, maybe. So step 1 is do some research. So this is finding other people that have done the work so you don't have to do it yourself. So how early do people arrive for their flight? Most commonly it's 1.25 hours. This is from a study at Christmas in Italy. Yeah, it's close enough. And what does it actually look like? Something like this. So most people around the 1 hour to 1.5 hours, and some in the tails. So step 2 is let's collect some data. So we need to know which flights are actually leaving Adelaide. And there's a flight-aware API for that, and we can just ask, well, how many flights are leaving Adelaide? Gives us a great list. Awesome. We also need to know how many passengers are on each flight. The API has most of those values, but unfortunately, that doesn't have all of them. So there's some manual data collection process. Now, in this, I was expecting, single plane, they'll have the same number of passengers. No, not even by airline. So sorry for all the plane nerds, close enough is going to do. And now we need to make some assumptions about all the data in the model. So I'm going to ignore that we have international flights that you have to arrive earlier for. Everything's a domestic flight. Also going to assume that the planes aren't quite full, going 95%. Also, any check-in or pre-stuff that you have to do, add that time on yourself. Also, we want to make it through security or get to security 20 minutes before the flight departs, so we can run from security. If you're on a gate a long way away, I hope you can run. And the target queue time for security is 15 minutes, which we will get to hopefully in the second part of the model. So to do this building a model, look for every person that's coming into the airport, pick how early from our distribution they're going to arrive for their flight, subtract that from their flight time, and then count up all the people, and it looks something like this. So something that will be quite, noticeable is at about just before 4, there's a very big dip. That's going to be very useful for those of you that have flights close to then. But have we actually answered the question? We've worked out how many people are arriving, but not how long the queue is and what the optimal time is to actually join that queue so you get through get to the security. So let's do some more research. So how many people do we actually get through a security lane per minute? On average, it's 2.5. And there's some research behind that. And then we also need to know the number of lanes at the Adelaide airport, and there's 7 of them. 1 is actually hiding, so I hope you can find it. So we need to model the people arriving at security and how they queue there. So not all the lanes are going to always be open because that costs money. So when the queue gets too long, we're going to add some extra lanes, and when there's no demand, as in the queue gets short, we'll take them away. And there's some model-y stuff around that. But what happens is we get a queue time that looks something like this. So yeah, at around that 3:30, we've got our 5-minute queues, as well as at about 7 p.m. And putting that all together, when should you arrive? If your flight's on there, you can join the security snake at whatever time is in the appropriate row, and you'll get through security 20 minutes before your flight. For those of you that aren't on this list, there's some more on the next page, maybe. No, it didn't update. But yeah, that's when you should arrive to get to your flight on time. Thank you.
Hey, thank you for that. Okay, down to 2 talks. Up on deck we have Katie, and we've gone from one talk which is about snakes to board planes to Ella, who's going to talk about Python on a scientific research ship.
Hi everyone, my name's Ella. I work on the RV Investigator, which is CSIRO's research vessel. I thought I'd just give you a really quick overview of what the vessel actually does, rather than anything too technical, because there's some pretty cool stuff going on there. So just a little bit about the vessel to begin with. It's almost 100 metres in length, commissioned in 2014. There is about 20 ship crew, so that's like the master, the deckhands, all the people actually working on the ship. There's 10 CSIRO staff, so that includes me on the data acquisition and processing team. We have geophysical survey mappers, we have electronics, and we also have hydrochemistry. And we work on there in 12-hour shifts covering 24 hours worth of range, so either 2 a.m. to 2 p.m. or 2 p.m. to 2 a.m. And then we've got 30 science participants. So they apply to be on there. They can be from within CSIRO or from Australian universities or any kind of research that happens within Australia, and they apply to come on and use the ship. Here's just a little map of some of the places we go. We do go all the way around Australia into the Indian and Pacific Oceans, and often, at least once a year, we will go down near Antarctica to have a look at what's going on down there. So this is just some broad overview of the capabilities. There's lots of labs. We can add containers on. There's sonar. We've got drop keels. We've got something called DMV silent rating, which makes us a really good scientific ship. We can do sediment coring and a few other things, and I'm going to show some pictures of. So the first one is CTD and water sampling. So on the way down, we get oceanography, and on the way up, we get water samples. These are then analysed by our hydrochemists, and there's just a picture of the ops room and what that looks like. It can get very full of scientists when they get excited. Then we have the geophysical survey mapping. So we have lots of sounders on board and some really cool stuff going on. Here we've got the Cocos Islands. We did some mapping of those, which the scientists love, and we also had we have a lot of shipwrecks come through that everyone seems to love the shipwrecks. Everyone thinks they're pretty cool. Lots of back deck deployments, not too much data for me on these ones, but there is data being collected. We do some fishing, so we get biological, we get coring down on the ocean floor. We've got weather balloons, lots of good stuff, Argo floats, long-term moorings. And then we also have the atmospherics. So if you look up at the middle, I'm running out of time. If you look up at the middle one, that is the Met and Atmospheric Station, and then the two balls on the sides are actually our satellite communications. And finally, one of my favorites, the deep towed camera. So that gets put into the water and we get to see video of the ocean floor. Where does Python come into this? It comes in when, or for me at least, in data acquisition. So we've got that system here of the CTD, all those different atmospherics, temperature sensors, water sensors, everything you can think of. And we'll put them into a program, an open source program called OpenRVDAS, which is Python. We're using tons of really good stuff in there, making contributions. We've got a lot of research vessels around the world who are using this program. And I think for any hobbyists that just want to collect some data, you can read it over UDP, you can read it over Serial, you can read it over File. It's actually a super cool program. We then spit that out to files, to timescale, to, and then send that off for people to use back on shore. We also have, I've seen some Grafana coming up in people's presentations. We use Grafana to view all this data live to make decisions about deployments and what we want to do on them. Those VSATs that I was showing you before, they can make things extra interesting because we don't always have the same cloud integration that some of you guys might be used to. Everything has to be done on the ship. We don't always necessarily have guaranteed connection back to shore, but very exciting, we did just put on Starlink and it is going quite well. Yeah, so basically lots of really interesting stuff going on the Investigator. If you want to come and have a chat to me about any of those things, please let me know. And yeah, I reckon I'll leave it there.
That is your job? You delivered that so casually. You sound like a scientific adventurer.
Not compared to the scientists.
Okay, up on deck we have Daisy. And I lied earlier. I said there are only 2 talks that are on the same subject. Well, I found another 2 talks that are on the same subject. We have another speedrunning presentation. Welcome, Katie. Sorry, a presentation speedrunning.
Excellent. Hello. The very first thing I have to tell you about public speaking is that you might freak out. Here's a secret. Everyone freaks out. Even the most experienced speakers freak out. But giving a presentation in front of people is actually super intimidating. But as soon as you start getting going, everything seems easier. But what if they hate my talk, you might think? Here's one thing to remember. People came to your talk for a reason, probably because it's in a set of lightning talks and they can't leave. Not to see you crash and burn, though, but they want to learn something from you. People are going to remember your talk for you, not your slides. Slides are a mechanism to help you remember the points you want to tell and your story, and you get to have cool pictures. But I'm not a lecturer. I'm not teaching. You You are, though, you could be teaching people one of two things, something they didn't already know or reinforce something that they already know, which is super useful. And now the most important thing I have to tell you about presenting to an audience is they do not care what you did. You wrote 1 million lines of code. Pfft. You worked out how to create widgets to help synergize the fiscal prudencies at FUBAR-Conf. They care about why. Why did you do the thing? There's power in stories, but especially for technical presentations, tell me how you did the thing. Let people be able to play with the toys that you had so much fun with, and then they can learn and do that on Monday at their office at their desk. Once you have an idea, now you have to bring the content, which probably means slides. You don't have to have them. I like them. So let's talk about that. Here are opinions. Some things to do. On average, aim for about a slide a minute. Lightning talks don't count. Pick one thing that you want people to remember after your talk. Do not assume any technical or prior knowledge level of your audience. Fit your audience. A work presentation will feel different to a meetup or a conference, but it might use the same deck. You are allowed to do that. Fun fact, I've presented this deck exactly as is at all 3. Use images to help people visualize what you're saying where appropriate. Do the actual demo if you have one. If you're going to put words on the screen, make sure they are legible. Use speaker notes to help you remember what you say. Practice your talk. You got to practice, I know it sucks. You also need to time your talk. And you got to practice, I know it sucks. But you don't have to be speaking the entire time. Take a drink of water. Don't do walls of text on slide. It is really distracting. If you have a demo, do not fake it. Do not use memes. They distract people from your content. Cat pictures are only okay if they are part of your demo. Do not read your slides out loud. That's what blog posts are for. You are on stage. Perform. But there's such thing as overdoing it. If you're co-presenting, don't try to fake banter with your presenter. It's really weird. If you've been practicing, you don't have to. You know when you're supposed to talk. You do not have to take questions. Answering questions on the fly is a completely different skill to giving a presentation. You are absolutely more than welcome to say, I'll answer that in the hallway later, thank you. Do not use TLAs, 3-letter acronyms. The one thing you can end up teaching your audience is how to use your 3-letter acronym in a sentence. But Katie, I hear you lament, it's just too hard, I have so much to do. Well, yeah, a 15-minute presentation is not going to be written in 15 minutes, more like 15 hours. You have to set aside time to prepare and practice your talk, and this all takes time. But Katie, what if my presentation is boring? People have chosen to attend your talk to hear what you have to say. But you are never going to enrapture 100% of your audience. Find the people who are engaging with you and talk to them. But Katie, I don't know what to say. Well, here's my easy 8-step plan. Pick your main point, write a rough outline, write a script, cut that script up into slides, add some visuals, read it out loud to someone else if possible, plushies count, and time it. With presentations, you are giving focused technical content within a fixed time with accompanying visuals. Practice to ensure you finish within the time allowed to respect your audience. And practice it. Again, thanks, but one more thing. You are not Steve Jobs and neither am I. There is no one more thing. You do not have to have a gimmick to make people want to pay attention to you. Your audience wants you to succeed. They want to learn from you. They are your allies in this. And they're probably really happy that it's you on stage right now and not them.
1 minute.
Thank you, Christopher. Just be you and all else will follow. You've got this. Thank you.
So, Libby, what did you think of that talk?
I feel very perceived, particularly with the line about not faking banter. What do you think?
I think that's fascinating, Libby.
Profound.
Thanks, Katie. That is the last of our lightning talks for today. Everybody, please thank our presenters. Also, thanks to David and Evan, the Lightning Talk elves for this year. And the person who we gifted a scepter to several years ago and now can't get rid of her, Libby Berry.
I didn't ask to be thanked. What is
And
this?
of course the AV people for making this look seamless as they always do. Lightning Talk submissions will be open at morning tea tomorrow. If you're inspired by this and want to give a talk, you should definitely give a talk. And I will definitely send out the notifications on time so you have an adequate time to prepare your talks.
Lastly, thank you to Chris.
See you tomorrow. Here's Daisy.